topic P4.1, electrical charges and fields. Just going to recap what an atom looks like. Centre of the atom we have a nucleus. Inside the nucleus we have protons and neutrons. Protons are positively charged, neutrons are neutral. Around the outside of the nucleus of an atom we have electrons that are rotating around, and these have a negative charge. An uncharged atom has equal numbers of electrons and protons, like we've got here. Only electrons can be transferred between different atoms. So the protons and neutrons stay where they are, but it's just the electrons that can move about. They can go away or they can come back again. Everything else stays the same, it's just electrons that can move. A charged atom is called an ion. Adding electrons to the uncharged atom makes it negative, because if you're adding more electrons, you're adding more negatives, so there's more negatives than positives. So that means that there's more electrons than protons, more negatives than positives. An example of that is here. So I've got two different atoms. This one is the same as we've got above, and it's got 4 protons in it, which are the red circles, and it's got 4 electrons. So the pluses and the minuses cancel each other out and they're balanced out. But if we add electrons to this same atom, we can see that we've still got 4 protons in the middle, so 4 positives in the middle, but we've actually now got 6 electrons. So that means there are now more electrons than protons, so there's more negative charge than positive charge. This means that this ion is now negative. So we've got 1, 2, 3, 4, 5, 6 negative charged electrons, but only 4 protons to balance them out, so there is more electrons, making this ion negative. Charging by friction. So friction is when we rub two things together. So if you rub your hands together, you can feel them getting warm. That is because of friction. Some insulators can become charged when you rub them. So if you've got a ruler at home, or something that's plastic like that, rub it up and down your clothes and you'll notice static is formed, and that's because it has been charged by friction, so some of the electrons have moved. When you rub an insulator, electrons are transferred from one material to the other. Remember, we said it's only electrons that can be transferred. I've got 2 examples here of objects that have been rubbed together. So we've got a polythene rod and a perspex rod, and these 2 different things. So I've got a dry cloth here. If I rub the dry cloth on a polythene rod, electrons gained from the dry cloth are negative, so the electrons from the cloth have transferred to the rod, making the cloth positive because it's lost electrons, so there are more protons in the cloth, making the cloth positive. The electrons have transferred to the rod, making the rod negative because there's now more electrons here than protons. Moving over to the other example, this is the opposite way around. I've got a perspex rod and a cloth. Initially they're both going to be balanced, but when we start rubbing them together, the atoms have become positive as a result of losing electrons. The electrons come off the perspex rod and go into the cloth. So it loses electrons, making it negatively charged, making the cloth negatively charged. It's now got more electrons and neutrons, but the perspex rod has lost electrons, so it's now become positively charged. Looking at the force between 2 charged objects. 2 charged objects exert a non-contact force on each other, so they don't have to be touching to exert a force on each other, similar to magnets. So it's a non-contact force. Electric fields are the same, they don't need to touch to have an impact on the other object. A charged object has an electric field around it, and other charged objects can feel this. So if you've got a charged atom, it gives off an electric field, and whenever 2 charged atoms come together, they can interact and they'll feel the force of each of these fields. So the force between 2 charged objects becomes stronger the closer they are together. So the closer these 2 objects are together, the stronger this force field becomes. So if we have a look at a diagram I've got here, this is looking at what the force lines will look like on a charged object. So if I've got a charged object here, this is positively charged, just for the base of this example, and these lines are the direction that the force is going in. So each line of force is a path that a small positive charge called Q would follow because of the electric field. So because it's positive, it's going away from the centre of the sphere. If the sphere was negatively charged, lines would be going towards the sphere, so in the opposite direction like I've got in this diagram. The lines point away from the centre of the sphere because the force Q, so the force is called the letter Q in this, is directed away from the sphere. Okay, so positive go away, negative go towards. These lines represent the direction that force is going in. So if you have a positively charged ion, this is what would be happening to it. And finally, if two objects are oppositely charged, electrons from air molecules between the two objects experience a force towards the positive object. So air is charged, it has different particles in it, got different charges. So I've got two objects here, a positively charged object and a negatively charged object, and this is the air in between. The electrons, which are negatively charged, will naturally move towards the positive object. This is what that sentence is saying. If the field is too strong, sparking happens because some electrons are pulled out of this air in the middle by the force field that surrounds the object. These electrons hit other air molecules and knock electrons out of them, creating a sudden flow of electrons between the two objects. Remember, the same as magnets, like charges repel, unlike charges attract. That's the same rule for electric fields.